Hi, hello everybody. Good morning, Andrew. What time is it
Hello, good
now?
morning.
Uh,
Thank you. So where I'm at, it's 10:15 a.m. on the East Coast of the United States.
okay, great. It's not too early, it's not too late, so it's great. And welcome, Igor. Actually, Igor is sitting next to me. Hi, how are you?
Yeah. Hi everyone. I'm fine.
Okay, cool. Yesterday there was a talk about about how manual testers can move to automation, and the presenter suggested Python language as a first language to learn. Okay, we always can argue about this because I personally from Java side, I'm a person from Java community, and I think Java is still a language for automation. But anyway, here we have a talk about PyTest, and I think it's an introductory talk. Andrew, when in every language, there are lots of testing frameworks. I can easily Google for about 6 frameworks for Python. Why are you going to talk about PyTest?
Great question. I'm going to talk about PyTest because, first of all, it is the most popular test framework in Python. Secondarily, I also think personally it's the best. PyTest is very minimal in that, for example, you write your tests as functions rather than as classes. It's also very Pythonic in a lot of its idioms. It uses things like decorators and some nifty dependency injection. So when I've looked at all the different Python test frameworks, such as Unit Test or Doc Test or even a couple others, Behave, I always come back to PyTest as my favorite, and I think it's the best.
Okay, great, great. So I think for those folks who listened to yesterday's talk and decided to start with Python, I think your talk is a good place to start. All right, let's proceed to your presentation.
Well, thank you so much, and thank you to everyone who has brought this conference together, and thank you for inviting me. This is my first conference I've ever spoken at in Russia, so this is a cool opportunity. Um, as everyone said, I will be talking about Python test automation with PyTest. I love Python. It's one of my favorite languages. I also know Java and C# and some others, but Python is my personal favorite. And I'm going to teach today about how to use PyTest, which is the most popular test framework in Python. If everyone can see my screen, I just want to shout out a few reference links so everybody can have them as we go through the talk. Today's talk will entirely be live coding. There will be no slides. We will be coding with Visual Studio Code and then running it at the terminal. So take a quick snapshot of these links so you have them handy for reference. All of the example code I'll be showing today is in this first link in this GitHub repository. My GitHub username is AndyLPK247. And the example code is going to be in a project called TAU, Intro to PyTest. So if you want to reference some of the code that we're sharing today, you'll see it all in there. Make sure you go to the examples develop branch because the master branch is empty. I also want to share some other links. For example, the PyTest docs are at docs.pytest.org. PyTest is a great framework not only because the code is good, but because the docs are stellar. Also, I want to share Test Automation University. TAU, Test Automation University, is a set of online courses about testing and automation available to anyone, anywhere for free. Personally, I have written a few courses on Python testing. There's a course on PyTest, there's a course on Selenium WebDriver, and there's a course on PyTest BDD. So feel free to check those out after the talk to learn more. And of course, my personal blog is automationpanda.com. So let's talk about Python. Python is a wonderful language. I've been doing Python for a number of years now. And what I love about Python is that it is simple and concise. I personally think Python is a great language for test automation. Java is a great language, C# is a great language, but Python is also a great language. Specifically, I think Python is a great language for test automation because it helps folks who are new to programming get into automating tests quickly. I think Python has a bit of an easier learning curve than some object-oriented languages like Java and C#. I find that in Python, I can do the same amount of stuff in fewer lines of code. I find those lines of code to be just a little bit more readable, a little bit more nice. So if you're new to Python, there are plenty of resources that you can use to learn Python. In fact, at Test Automation University, they have a free course on Intro to Python Programming. If you don't already have Python on your machines installed, you can go to python.org and easily download it. I believe the most recent version is 3.9. I'm actually running 3.8 on my machine. So to check if you have Python installed, you can always do python -- version. And so today, as you can see, I'm running on Python 3.8.4. Another little cool thing about Python is that it has an interpreter inline, so you can, type in expressions and do stuff. There's also a little Easter egg, import this. If you ever want to learn about the principles behind the Python language, type import this and you will learn the Zen of Python, which are 20 principles or so about why Python is the way it is. Things like beautiful is better than ugly, explicit is better than implicit. I take a lot of these principles when I do programming in other languages too. Oops. So I'm not here so much to talk about Python as I am here to talk about pytest. The docs are at pytest.org. I love the docs because they show exactly how to use this framework. We'll get into the code in just a moment here. I just want to show you, this is the doc site. I come here all the time, even though I'm using pytest as a quote unquote expert. I still find the docs very helpful. So pytest is a third-party package. It is not part of the standard library. So in order to use pytest, you will need to install it. To install Python packages, the standard way is to use pip, Python package installer. So we would type pip install pytest, hit enter. And if you already have it, like I do, you'll see messages like this saying requirements are already satisfied. If you don't already have pytest installed, you'll see it take a few minutes and do the download. Make sure that you're using a fairly up-to-date version of pytest. I believe they're on version 5 or 6 now. So now that we have our understanding of what is Python, what is pytest, why are we doing this, let's create a test project for Python and start adding tests to it. In the first set of tests, what I want to do is teach how to use the mechanics of the pytest framework. I'm fairly certain most people in this conference probably already know things like what is a unit test, and what's an integration test, and that kind of stuff. But the mechanics of the framework are probably new. So let's spend some time there and learn how to use pytest before we get hands-on with some more difficult tests. So what I'm going to do is I'm going to create a new project entirely. And we're going to call it Heisenbug pytest example. Now, you may not always want to create a new project whenever you want to do tests. It may be advantageous to put test cases inside of an existing project or repository. The times that you might want to do that would be, for example, if you're writing unit tests, of course, you want the code to align with the product code. Or, in my day job, I work on a very, very large web application for Precision Lender. And so we put our test cases inside the PL apps repository because we like to have them versioned together with Git. However, because today I'm doing something new, we're going to create a new project. So in Python, a project is literally nothing more than a directory. So I've created our folder. I'm going to change directory into that folder. And so we can see, hey, there we go. And It is convention within Python test automation that we create a subdirectory in our project named tests to hold all of our test cases. So now, if we look, we have our test directory in our project. This is fairly typical whether you're using pytest or unit test or most other Python test frameworks. It's fairly standard. If you ever go to a Python project or repository and you see a test directory, that's where you find the tests. So with our folder, our project, so to speak, created, I'm going to flip over to Visual Studio Code and start writing some tests. So we're going to open that folder. Oops. One moment. Heisenbug pytest example. Personally, I like to use VS Code for light Python editing. I find that the official Python extension for Visual Studio Code, which is now owned by Microsoft, is really nice. It's simple. It's not in your face. I've also used JetBrains PyCharm, which is excellent. PyCharm tends to be a bit heavier, so for this talk, I'm just going to use Visual Studio Code. So here we have our project. We have our test directory. And what I'm going to do is I'm going to create our first test case. Going to create a new Python module in the tests directory. I'm going to name it test_math.py. So py stands for Python module. Python module, also Python file, Python source code file, whatever you want to call it. Inside of our test directory, we're going to put this module. It's going to be prefixed with the name test_. And that's important because pytest will automatically look for test cases in modules named test_, or I believe also _test.py work as well. So this kind of tells pytest, hey, this is meant to be a module for holding test cases. Add a few comments at the top here. This module contains basic tests for math operations. Cool. So the first test case we're going to do is very simple. F test 1 plus 1. Assert 1 plus 1 equals 2. This right here is a fully fledged pytest test case. 2 lines. What's going on here? If you're new to Python, you might be like, what is this construct? In Python, the def keyword defines a function. Function, function name, parentheses, and colon, we don't use curly braces, with an indent. This is a function. This is also a test function. It is prefixed with test_, the same way that the module is prefixed, so that pytest knows to identify this as an individual test case within the test module. You'll also notice that there's this assert statement. The assert command is part of the standard language of Python. You can use asserts outside of pytest. What's really nice about pytest is that it uses Python's standard assert command. You don't need a fancy assertion library. The assert command takes a Boolean expression, which here is 1 plus 1 equal 2. This is a conditional check. And so if this is true, then the assertion passes and moves on. If this is false, pytest will, or the assertion, I should say, will raise an assertion error. Assertion error is the type of exception that the assert statement will raise if the condition is false. But this is why I love pytest. Right here, a very simple test case. It's very short and sweet, nothing fancy, regular Python functions, regular Python assert statements. So let's see what happens when we run this. I'm going to go to our terminal. And if we look inside our tests directory, we'll see we have our module now. To run pytest tests, we use Python as the command, -m pytest to say, I want to run the pytest module. And we're going to run this from our project root directory. We don't need to go into the test directory. We can run it from the project directory. If I don't specify anything else after the pytest command, pytest will discover all test cases in this folder. It runs very quickly. When we see this run, we'll see that pytest has this large banner of information. Things like, hey, I'm running on Darwin, which is Mac OS. I've got this version of Python, this version of pytest, these other different modules. It'll show the root directory from which it's running, which is my Heisenbug example project. It also shows any pytest plugins, and we'll talk about plugins a little bit later. Then it'll show the test modules, and for every passing test, it'll print a green dot. One test, one green dot. At the bottom, you'll get a summary. One test passed, so 0.08 seconds. Kind of slow, right? But that is how we can run our first pytest test case. We've gone end to end. We've created the function, put it in an assert statement, run it from the command line. Boom, it works. Wonderful. So what happens, though, if a test case fails? Right? We saw the easy case. Let's see the ugly case. I'm going to go back into our test module here. Now I'm going to add a new test case. Test 1 plus 2. Now this time I'm going to give some variables. A equals 1, B equals 2, C equals 3. And I'm going to assert A plus B equals C. So in the working case, right, 1 plus 2 should equal 3. But I'm going to deliberately inject the failure here. I'm going to say 1 plus 2 equals 0. We know this should fail. It should raise an assert exception. Let's run this again, see what happens. Oh, so this time when we ran, we see a failure. You'll notice by that test math py module, there's a green dot still. That was for the test 1 plus 1 that was passing, but in a big old red F for failure for test 1 plus 2. What's different in this printout, though, is that the summary has more information. What you'll see is that you'll see a banner for every single test case that has failed. You'll also see a printout of the code for that test case failure. pytest will point you to the line of the failure where that exception was raised. Here, the assert A plus B equals C. But moreover, you'll see another line below it that is very helpful. This line is the assertion introspection. Notice what it shows. Assert 1 plus 2 equals 0. It does an interpolation of the values of A, B, and C so that you could see from that printout exactly why that assertion failed. You don't have to debug to figure out what the values for A, B, and C were. You don't have to guess. You don't have to trace it through the code. pytest will tell you right away, oh, these were the actual values. So it's much more intuitive to you as the tester seeing this report. This is why the failure happened. It will also show you the type of failure. In this case, it was an assertion error, which is an exception type in Python. pytest will record failures for any type of unhandled exception. So if you have like a divide by 0 or an index out of range or your own custom exception that you raise, that will cause a pytest test to fail. Below the assertion introspection block, you'll also see a list of all test cases that failed. So here you'll see failed. You'll see the module with the test case that failed, : the name test 1 plus 2 of the test that failed, and the assertion introspection line that failed. So very, very helpful information pytest automatically gives you. Now we can't have a failing test. So let's go back and fix this and rerun it. 1 plus 2 is 3. If we're to rerun this again, everything should be fixed now. Very good. Cool. So now we've seen a passing test and a failing test. Let's look at some more advanced stuff. what if we want to test for an exception? Right? We saw that the assert statement would raise an exception when it fails, but what happens if we want to verify that an exception is successfully raised? Right? For example, let's make another test function. Test divide by 0. Bum, bum, bum. Okay. If we were to simply make a divide by 0 call, in Python, this should throw an exception. I'm going to run the tests again just to show what kind of exception it is. So that divide by 0 test did fail because this 1 divided by 0 raises what is called a 0 division error. Now, in this case, we want to verify that a 0 division error was raised successfully when we tried to do a divide by 0. How can we do that in pytest? Pytest offers a mechanism for catching exceptions and verifying them. First, what we'll need to do is we'll need to directly import the pytest module. Import statements in Python basically bring in other modules. We've already installed pytest with pip install, so we should be ready to go. Then, in our test case, what I want to do is I want to say with pytest raises, and I'm going to put that exception type, 0 division error. This should catch the exception and make sure it's okay. This pytest.raises, this is with this with statement. In Python, it's a special enter exit block. You can look up the with statement. It's standard part of the Python language. What it does is it says, okay, we're going to do some setup here, and all of the code within that block is going to fall in that setup phase. It's more common to use the with statement with file IO. Typically, you might see something like with, file path open, with open to a file path as some file pointer. But we can also use it with pytest raises. So if the code block does raise a 0 division error, it's a passing assertion. However, if this code block does not raise a divide by 0 error, then this will have a failing assertion and the test case will fail. So let's put that to the test. Let's run it again. And this time we should pass. Boom. 3 passing tests, 3 green dots, because that exception is now appropriately handled and asserted. If I were to toy with this a little bit, if I were to say assertion error, a different type of exception, then this test case should fail. It did not raise a 0 division error. Cool. Now there's one more trick we can do with this. We can not only verify that a statement raises an exception, but we can actually verify pieces about that exception. If I add as some sort of variable name, let's say as e, to my with statement, what this will do is whatever object is constructed by this setup routine will get referenced by that variable, so that after the with block, I can do something like this. Assert division by 0, that message is in the string for the exceptions value. So every exception has a message. What this assertion is saying is, hey, make sure that message, the string value of that message, contains this substring. That's what the in statement does in Python. One more time, let's rerun. Oops. And we're still good. Very nice, very nice. All right. One more pytest trick for this test module. A lot of times what happens with testing is that our test cases become very, very repetitive. For example, let's say we want to test multiplication. There are many, many ways to test multiplication. If you think about all the different equivalence classes of one number multiplied by another number, we could think that maybe we want to have test cases for multiplying two positive integers. Maybe we want to multiply positive times negative. Maybe we want to multiply negative times negative. What about by 0? That's the 0 property. Or by 1? That's a identity property. Or what about floating point numbers? There are lots and lots of equivalence classes we could come up with for a multiplication test. So if we were to write multiplication tests in PyTest, doing this, it would look probably like this. Test, multiply positive by positive. And we could do something like assert, 2 times 3 equals 6, right? And then I could copy and paste this whole nightmare and say, okay, well, what if I want to do a positive by a negative? 2 by negative 3 equals negative 6. And I could do the whole thing again and make it negative by negative. And that should give us a positive. And there are 3 more cases, right? But pause, timeout. This is becoming very, very repetitive. Even though this is only like a one-line test case, it shows that, okay, there are certain parts that just keep repeating. The procedure's the same. It's just we're changing the inputs. This can become a bigger problem for more complicated test cases. So how can we handle this? Thankfully, PyTest provides a way to parameterize your test cases, because we don't want to do this. A better way would be like this. First of all, let's separate our test case procedure from our test case inputs. What I really want is a test for multiplication. And for this multiplication test, what I want to do is I want to take 2 numbers and verify that they are multiplied together, they will yield a particular product. So I can write my assertion, rather than hard coding numbers, to say something like A times B equals product. This is a much more generic kind of test case. The only thing is we need to provide input values for these variables. In PyTest, how we will do that is we'll make a list of tuples. I'm going to call it products. It's going to be a list in Python, which is square brackets. And inside of here, I'm going to make tuples. And tuples are denoted by parentheses. So I have, let's say, 2 times 3 equals 6. That was my positive by positive case. I could also have something like 3 times negative 4 equals negative 12. And that would be my positive by negative 5 should give me a positive 25. I could have my identity property. 1 times 99 is 99. I could have my 0 property. Anything times 0 is 0. I could also have my floating point numbers. 2.5. Let's say 6.7. What is that going to be? 16.75. So now we have all the different tuples for inputs into our test function. The idea being they'll substitute in order A, B, product, but it needs to have the glue to stick that together. To do that glue, we're going to use a decorator on this function. It's going to be called pytest, coming from the pytest module, mark parameterize. That's the British spelling of parameterize, not the American spelling, much to my chagrin. Inside this parameterized decorator, we're going to write a string that represents the names of the variables which to substitute. So we'll have AB product. Excuse me. Then what we're going to do is we're going to pass in the variable for the list, which is products. What this will do is it will do some substitution and matching. It'll say, okay, all of the tuples in your list, products, boom, 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 we're going to consider them to be in the order of A, B product. And then we're going to match the names of these variables in the test function. So we will have a dependency injection here. So now this test case should run 6 times, once for each tuple in your parameter list. Let's give that a try. Boom, there we go. All tests were passing. Notice how we have 9 tests passing. Each one of those 6 from the product list was included as its own test case. That's the power of parameterization. Now, it's special, but it's not terribly special. I mean, most test frameworks are going to have some sort of parameterization function like this, like in JUnit or NUnit or whatever. But this is just how pytest does it. And the reason why I like pytest is because, in theory, we could use this parameter list for other test cases as well, if we needed to. So, very, very cool stuff here. So with that, I think we've covered the mechanics of the pytest framework decently well. We've shown how to write tests for basic math operations. Now, these are not real world tests, right? Nobody's going to be writing tests for Python's math operations unless you're actually working on the Python core language, right? Typically, people want to write unit tests or service API tests or something like that. Things that are actually testing code that you write. So let's pivot and make a class, very simple class, and then write some unit tests for that class. So what we're going to do is we're going to make a new Python package and put a new class inside. So up at the top level of our project, I'm going to create a new folder. Oops, no, I said at the top level of the project. I'm going to create a new folder, and I'm going to call it stuff. Inside this folder, I'm going to add a new module, and I'm going to call it __init.py. This is also called a dunder init module. Dunder init modules denote that their containing folder, the stuff folder, will be a Python package. What a Python package is simply an importable set of Python modules. So anytime you want to be able to import modules from another area or another module, make sure that you're creating packages to do that. So stuff is now a Python package because it has this dunder init module inside of it. We can leave dunder init blank. Doesn't need any code. You can also add some stuff in there, do some more interesting Python packaging things. For our purposes, not necessary. We just need the file to exist. Then inside stuff, I'm going to create a new Python module, and I'm going to call it accum.py. And this will have our class. This module contains a basic accumulator class. Always like to have top comments like that. So in here, what I'm going to do is I'm going to create a new class. In Python, you can have classes as well as functions. I'm going to call it accumulator. It's typically best practice in Python 3 that we make our class names capitalized. If you're new to Python programming, I'm going to drop some stuff here that may look familiar but unique. If you know Python programming, you'll understand what these things are right away. So in Python, we don't exactly have constructors for our objects. We have init methods. So they do the same thing, mostly. There's a little bit of nuance, but effectively for our purposes, they do the same thing. So if you're used to Java, this would be like an accumulator constructor. The name for the init method is dunder init. Dunder comes from double underscore. Def init, the self variable here is referring to a reference to the object that is being constructed. Self is like this in Java or C#. And what I want to do is I want to say self underscore count equals 0. What this is doing is that it is creating a variable named underscore count, attaching it to the current object self, and initializing it to 0. Why? Because if we create a new accumulator class, we want it to start at the value 0 because it hasn't added anything yet. In Python, this single underscore denotes that this should be a private variable, though warning, in Python, nothing is truly private. The underscore for privacy is simply a convention to be respected. You can't make any variable truly private in a class. So what I'm going to do next is I want to provide an accessor to that count. I'm going to create a new method that is a property. This at property here is a decorator to say the following method is going to be a property, meaning a getter, an accessor. So I'm going to say def count self, and I'm going to return self underscore count. What this does is it provides a way to publicly access the count value in a proper way. By creating this property, it will also prevent callers from directly setting the count value. Theoretically, they could still set underscore count, but it has a semblance of somewhat privacy. So then I'm going to have one more method called add. It's going to take the self, and it's going to take a value to add. I'm going to say self dot underscore count plus equals more. What this method does is it will take in a value called more. The default for that value is 1, but you can override it if you want. And I'm going to increment the count value by whatever that additional amount is. So even if you're not familiar with Python, this code should be fairly intuitive, right? It's just an accumulator. You create it, it starts at 0, you start adding things to it, and then you can check the value at any time. Let's write a unit test for this. I'm going to go back to my tests folder. I'm going to create a new module. I'm going to call it test underscore accum.py. Quick note. Notice how our stuff package has an init method, but our tests folder does not. With pytest, you do not need to make your test folder a package. You do not need to have a dunder init method or a module. Just FYI. All right. So now that we have our accumulator class, let's add some unit tests for it. First test we're going to have, or let me top matter here. This module contains unit tests for accumulator. Cool. So let's make some test methods here. Test accumulator init. So what I'm going to say is accum equals accumulator. And for those, oh shoot, I forgot something. We need to import. Sorry about that. From stuff.accum imports accumulator. This will import the accumulator class from this module in this package. Making it a package enabled us to do an import like this. So we have the accumulator class. what I'm going to do is I'm going to say accumulator equals accumulator. This is how we would initialize objects in Python. Don't need a new keyword. Kind of confusing at first, I know. Assert accum.count. Expect that to be 0. Let's give this a test. We're going to run the full pytest suite again. And this time, what we'll notice is that we now have a new module of tests, test accum, and the one test passed. Great. Still pretty quick, which is nice. Let's add some more tests here. Def test accumulator add 1. These are all going to be fairly similar here. So create my accumulator object again and say accum.add. We're going to leave it with the default value because it should be 1. And we're going to assert accum.count is 1. Let's do another one where we set the accumulated value. Let's say 3. Here we can set this to be a 3, and then that should be a 3 too. We can also do a test where we call the add method multiple times. Because we would expect if we add and then we add again, they should accumulate, they shouldn't replace. Finally, it might be good to have a quick little test for that property, because properties are supposed to be read-only. Test accumulator cannot set count directly. And we're going to use that with pytest raises. I'll need to import pytest. I often forget to import things and then I wonder why my code breaks. It's okay, it happens. With pytest.raises, and I want to make sure I get an attribute error here. Oops. What I'm going to do is I'm going to attempt accum.count. I'm going to attempt to assign a value to that, and it should fail with an attribute error. So here we have 5 unit tests now. Very basic because they're a basic class. But they show how you can make a class, call some methods, test some things in different ways, and everything should work out. Let's go back to the terminal and run these bad boys. There we go. Boom, everything passed. Nice, nice, nice. Now, these test cases are good, but they're not great. There's something that I'm sure you've noticed by now that is not so good about them, and that's a lot of repetition. Every single one of these functions has a instantiation call for the accumulator class. That's very duplicative. We don't like duplicate code. We don't like to repeat ourselves, DRY principle. And this is especially acute in test automation because test automation has a lot of repetitive operations. So what we want to do is we want to have a way that we can kind of, avoid this duplication. To do that, we're going to use something called a pytest fixture. If we were doing JUnit or NUnit or some other language, we'd probably have like a setup method in our test class. Since pytest uses functions instead of classes for test cases, we don't have that. But what we do have is a pytest fixture. A fixture is essentially a setup/cleanup function. To declare a fixture, what we do is first, we make a function that will do some preparation or do some setup, do some initialization. So I'm going to call my fixture def accum, and I'm going to make it construct an accumulator object. Fixtures should return the objects that they want to construct. I'm going to say return a new accumulator object. What this does is it constructs this thing and it'll return it. To declare this as a fixture, we're going to add a decorator, pytest fixture, which basically just says, hey, pytest, this is a special kind of function. It's got this special decoration to it. Handle it in a special way. Now that we have our fixture defined, what we can do is we can copy its name, and this is going to get really cool. We're going to add that fixture name as a parameter to our test case. Whoa! What's going to happen here? What'll happen is when pytest runs this test case, it looks inside this list of test function parameters to see, hey, what are these things? It will then try to match names of any parameters to any available fixtures. And if you have a matching name, what it will do is pytest will call this fixture and take this value and assign it to this as a variable, so that now we can eliminate our repetitive calls to the accumulator constructor. This fixture declaration now becomes an object that is the returned value from that fixture. And so I can use it and just say, assert my accumulator count equals 0. I can call it here. I can call it here. And just like that, we've eliminated all that duplicative code. Oh, it's wonderful. This is why I love pytest. Every test case will get a fresh version, assuming you don't add any particular scope to this fixture. So that means with these 5 test cases, each one will call this fixture and get its own object. You could change fixture scope if you wanted to share, for example, one object across all tests. That would be useful, for example, if you're connecting to like a database, or you have some sort of shared data that you're trying to share. But because these are unit tests, we really want them each to have their own instance. So we don't want to do anything like that. So let's verify this works. Let's run these tests again. Boom, everything works. Awesome. If there is one feature in pytest I think knocks it out of the park, it's fixtures. This is what really differentiates pytest from not only other Python test frameworks, but other test frameworks in general, right? Probably the most popular format for a test framework in any language is the XUnit format. If you use JUnit or NUnit or even pytest's unit test, the idea that you have a test class with a setup method and a teardown method and methods for each individual test case, that is what we refer to as an XUnit style test. The problem with XUnit style tests is that I find them to be a little bit clunky. I don't think a test case is the best construct, or I don't think a class is the best construct for a test case, because a test case is simply a procedure. I think functions, being a little bit simpler, 1 through n steps, are much better suited for that. Then when you start to put things into test cases, or when you start putting test cases into test classes in the XUnit format, you hit issues where you can't share your test cases simply by declaration. And their values are passed through using dependency injection, which is a very good pattern for appropriately sharing scope. So this is one of the main reasons why I love pytest. This comes in handy when you do things like web UI testing, where you want to pass in an instance of your WebDriver, right? Cool stuff here. Another thing to note with these unit tests here is they implicitly use the arrange, act, assert pattern. Arranging with a fixture, acting, let's say by calling methods, and asserting by checking outcome. Arrange, act, assert, fairly standard pattern for test cases, applies in pytest just like anywhere else. So, pardon me. Now that we've seen some unit tests, what I want to do is I want to up the ante. We've got about 10 minutes left here, so let's do a REST API test. What we're going to do is, one moment. in order to do REST API testing in Python, we need a module called requests. Requests, I believe, is the most popular package of any type in Python. It allows you to make REST API requests super simply. You can say request.get, request.post, and then everything is automatically parsed for you. Check out the doc page for requests when you get a chance. Make sure you pip install requests because it is not part of the standard library. I already have it installed, so we should be good to go. So let's create a test case using requests. Test underscore REST API.py. This module contains REST API tests. So what we'll need to do for this is we will need to import requests. Oops, no. There we go, this should be good. And we also need an API to test. So in a lot of my examples, I will use DuckDuckGo, which is just a search engine. DuckDuckGo provides what they call their instant answer API. The instant answer API basically just gives JSON answers for queries you have. So for example, here's a query, api.duckduckgo.com/question. Your query is what DuckDuckGo is. You ask this and you can get a JSON response. Fairly simple kind of thing. So let's write a test case for this. Test DuckDuckGo instant answer API. To arrange this test, I'm going to say my URL equals https://API.duckduckgo.com query, let's say Python programming, something fun. And we can say format equal JSON, just so it's nice and easy. So this will be my get endpoint for calling the DuckDuckGo instant answer API. If I'm going to act, response equals requests.get, what my URL is. Super simple. I love it. The body for that is response.json, and this will give you a Python dictionary already parsed. So next, what I can do, I can make assertions. What do I want to assert? Well, let's make sure that my response status code is 200. And also, let's check some of the content. Let's make sure that the word Python is in my body dictionary value for abstract text. This is all we have to do to write a REST API test in Python with pytest. Again, it's super simple. Pytest makes it easy to set up the test case. Requests makes it easy to call the API. One of the most powerful things about the Python language is that everything seems to be an import away. I don't need to have a whole bunch of long code. I can do things nice and tight and simply. So let's run this test now. And hopefully it works. I didn't screw up. Oh, shoot, that was... Well, I screwed up because I didn't run the right command. Let's try to run the test. Boom. Everything passes. Nice. Cool. So in the few minutes that we have left, I just want to show a few more little Python tricks and give a few more references. pytest also has a very rich command line. You can do things like check for help. Oops. --help. So you can see any of the command line options or pytest init options here. Oh my gosh, this thing is super long. But just note that --help can get you the help commands. Some other useful things for pytest would be, let's say instead of running all of the tests, you wanted to only run a couple. You can do things like specify the module that you want to run. So let's say I only want to run those, the math tests. Here you can see I filtered down and ran only the math tests. You can also run individual test cases using : and then the test name. So test1 plus 1. And that will run exactly one test case. Nice. If you want to do some pattern matching for filtering, you can use the K option. I can say -K and say, I want to run any test case that has the substring 1 in its title. So here now, there were actually 3 test cases, 2 in the math module and 1 in the AQ module that had that name 1 in there. And you can see 3 tests passed, 12 deselected. So pytest offers you a lot of really nifty filtering things. You can even add marks to your pytest test cases, which I don't have time to show today, but definitely go check that out. Let's see some other real quick interesting things. What I'm going to do temporarily is I'm going to inject a failure again so that we have at least one failing test. And I'm going to show two options to control how verbose things are. So if we were to run the tests just the way they are with this one failure, we'll see that we have that red F. We see that we have the failure banner. This is all fairly standard. I can be more verbose about my results, -- verbose. When we run with a verbose command, we see our banner has a lot more information in its metadata. We also see not only, we don't see the dots anymore. What we'll see is actually a full list of every single test case from every single module and whether it passed or failed. So here we can see everything passed except for this one that we injected a failure in. And it shows the introspection of why that failed. We can also go the other way. Instead of being verbose, we can be quiet. Here, we didn't even have that opening banner. We literally had all the dots, not even separated by module. We still have that failure introspection, which is really nice. But just being quiet is less text for cluttering your console. It might be worthwhile to use the quiet option in something like a continuous integration system. So before I forget, let's undo that failure and just make sure everything works again. And so when you have all passing tests with quiet, you literally get 2 lines, which is really nice. So there's a lot more I could say about pytest that I could cover in just this short hour. Some other things that I would definitely recommend checking out with pytest are plugins. I mentioned them before. Hold on, it might be pytest. Google can help us out with this one. Here we go. So you can actually extend the pytest framework with plugins. It's a way to extend what pytest can do. And there are a lot of plugins already out there. Let me find this list here. Here we go. So you can check a list of popular plugins out there. A few plugins that I like to use would be pytest HTML. pytest HTML will generate HTML reports for you, so you don't just have your results in the console. Another one, pytest cov. This is a wrapper for the coverage py module. What pytest cov does is it adds code coverage to your pytest results. Also pytest xdist. pytest xdist is a plugin for running tests in parallel. You can run 3 tests, 5 tests. You can run them on the same machine. You can run them on multiple machines. Very, very helpful plugin. And then there's also pytest BDD, which lets you write feature files using the Gherkin language for your test cases instead of pytest functions. So if you want to learn more about pytest and Python automation in general, definitely check out Test Automation University. Wait for it to load for just a moment here. Test Automation University has a ton of courses on everything related to testing and automation. I've written a couple PyTest courses out here, but it also has courses for pretty much any language, Java, JavaScript, C#. They're free to take. Wealth of information from industry experts, definitely worth the time. So for example, here's that Introduction to PyTest course that I mentioned. I know we didn't have time to look at web UI testing, but if you want to learn how to use Selenium WebDriver with Python, there is a pytest, or there is a Test Automation University course that I've done, Selenium WebDriver with Python. And so it'll use pytest and show you all the things. So that is my talk. And I hope everyone got to learn a little bit more about Python, got to learn about pytest. And I guess we can open up for questions now.
Okay, Andrew, thank you very much for your presentation. We have a number of questions here in the chat. Igor, it's your turn.
Yeah, sure. The first question from our visitors is, what is your favorite way of handling dependencies and virtual environments? Maybe requirements, TXT, poetry, pyenv, ppenv, or even Docker?
Oh, great question. Great question. My preferred way these days is to keep it simple. I like to use Python's VNV module, Python VNV, which is kind of like a successor to virtual environment or virtual env. And what I'll do is I'll set up my environments locally with VNV, and then I will save them to a requirements TXT file. That seems to be the traditional way in Python to handle dependencies. It's also the most universal way. I have used pipenv in the past. It's a decent tool. I have friends who use poetry. They love it. So yeah, it's all good.
Yeah, okay. Move to the next question. The question is not about PyTest. What do you think? Is Nose test framework is it dead or not?
Oh, yes, Nose is dead. Nose is long dead. I think even if you go to their page, they even say they're dead. Let's see here. Yep. Nose has been in maintenance mode. Boom. So yeah, Nose years ago was very, very popular, but the project is basically abandoned now, and PyTest has eaten its lunch, so to speak.
Yeah, and maybe some other test projects are good and have a good maintenance right now. Not only PyTest is a good choice for every case.
Yeah. So in Python, there are numerous test frameworks. The most popular ones based on what I see would be PyTest, number one. Number two would be unit test. And unit test is so popular because it is in the standard library. You don't need a third-party install. And so unit test gets maintained with every release of the Python language. There's also doc test, which allows you to write tests directly in doc strings. Behave is another popular Python test framework. What makes Behave unique is that Behave is behavior-driven development. So Gherkin, given, when, then, all that good stuff.
Andrew, in the very beginning, you mentioned that in PyTest we rely on assert and on standard assert, while this is due to beautiful introspection, of course. As far as I know, in Groovy we also have this introspection, while in other languages like Java and JavaScript, we have to use assertion libraries. What about Python? Do we have assertion libraries in Python? Can you suggest them, or do you prefer using assert only?
That's an excellent question. And for me, that really depends upon the test framework in Python I'd be using. If I'm using pytest, I would strongly recommend not using an assertion library. I would strongly recommend using the basic assert statement because pytest is already set up to introspect and handle that. In fact, let me look at this real quick. Assertion introspection. I believe that there is a way in pytest that you can develop your own custom assertion introspection. So if you look at the assert page on the pytest docs, it should explain how to do that. So you don't need to use a custom assertion library with pytest. You can actually improve how pytest looks at assertions, which is really, really cool. However, if you're using another library like unit test, I believe unit test comes with its own assertion package for custom assertion methods. Beyond that, I'm sure that there's probably some sort of custom assertion library out there in the wild in Python. Personally, I don't use them. I stick to pytest. I stick with the basic assert statement. Keep it simple. It's really good. I don't need anything else.
And we got another introspection-related question in the chat. Alexei asks, can I make a linter part of test to raise an error if there is a redundant line break in the code? So can our tests in PyTest test the code itself?
Ooh, that's a great question. I honestly don't know. There might be a way you could hack that in, but I don't know off the top of my head. I'm sorry.
I just think that it's the area for code formatters or maybe linters in Python ecosystems. We have some tools like Black for code formatting or Flake 8 or PyLint for linting. So I think its question is not about PyTest, but more about...
we can run a linter in a test method, for example. So it will fail if linter returns non-zero result. Maybe somebody will want to use it this way. I don't know.
Perhaps.
Okay, I have one more question from me.
Sure.
In PyTest, tests may be written as functions or as a class methods. Which way is main for you? Which pros and cons do you see in each options?
Sure. So the standard way and the way that I like to write my tests in PyTest is to use functions. I like functions because, like I said before, I think they represent what a test is at its heart better than a class does. I think it's a little bit simpler, especially for folks who are new to test automation and possibly even new to programming, right? If you have a lot of manual testers who maybe have not done as much programming before, and now they're picking up test automation, having that nice, easy learning curve. Functions are simpler than classes as concepts. So I personally like to write my tests as functions. I know that PyTest as a test runner can run tests from other Python frameworks. So for example, if you are on a project that has written a bunch of test cases using Python's unit test format, which have test classes instead of methods and stuff. What you can do is you can kind of draw a line in the sand. You can say, okay, we'll keep those unit tests the way they are, but new tests we'll write in pytest. The pytest runner can identify either unit tests or pytest tests and run them together without a problem. So theoretically, you could write them either way in the same project. Doesn't matter.
Okay, we have one more question from Alexei. During the session, you run tests with Python -m pytest. Why you don't use just running tests using direct pytest command?
Oh, that is an excellent question. It's probably something I should have brought up. So when you for a lot of tests, you can just run with pytest like this. The problem is if you use this command, it may not always link all the paths together for you. Let's give this a try and see what happens. Boom. So when I ran it just with pytest, not with python-m, it had an error collecting tests. The reason why is if you use just the pytest command, it will not automatically add the current directory to the Python path. So you'll see here, the error was no module found named stuff. It didn't know where to look for the stuff.accum pytest module. So because that wasn't added to the path. If you run it with the python-m, using the Python command, it will automatically add your current directory to the Python working path so that now when you run tests, it'll have your Heisenbug pytest example project in the path to link everything together. And so we can run our tests successfully. I know it's a bit of a pain, but yeah, I always run my tests like this.
Okay. Thank you, Andrew, for your talk. Thank you for the discussion. And to end with this discussion, I will just read the comment from the chat from Maria that thanks you for a nice talk, and she tells that she will definitely recommend it to her colleagues to start learning Python. And I can just join Maria. I think it's a great introduction to pytest and Python. And everybody can, and I believe should, proceed to Zoom call after this session to discuss further questions, to discuss maybe details that we hadn't time to discuss right now. So, folks, let's move to Zoom. And I must you must remember that you, Andrew, have to choose the best question after Zoom session, and the person who asks the best question will get a free book from our partner, DMK Press. Yes, so please try to remember all the questions and choose the best one. Okay, so see you in Zoom. Thank you very much for the session.
Thanks so much.
Bye-bye.